Hello, and this is my name is Daniel Russo. This is homework number 6, problem number 2 for EL 6303. And we're told that x and y are independent random variables. Common PDF x e to the negative x ux. F y is e to the negative y u of y u. And those both follow a very simple slope. And we're told to find the PDFs of the following random variables. So A gives us x plus y, and we'll consider that just, z. So we need to find the fz of x, y, which is equal to f of x of z basically f of x of z convolved with f of y of z, which is not difficult to sub in for in this case. In this example, think of y as equaling z minus x. So from negative infinity to infinity of e to the negative x u of x multiplied by e to the negative, now would be y, but we can sub in here as z minus x u of z minus x dx. Now these functions can give us more defined limits, as step functions can do for us. So if this is going to trigger, imagine x is triggering here, and z minus x, so z would be higher than x most likely. So x triggers on here, and z triggers there. It's going to be like our limits there in this area. So when you remove the x's, which are variable from each of those, you just think of it as 0 to z. E to the negative x multiplied by e to the negative z minus x dx u of z. So we removed our x's, kind of shifted them. So we know that this function at 0, that's the limit. That's where x will not go beyond that. So now we can integrate, but we can actually simplify a little bit as well. This is going to be e to the negative x minus z plus x. Sorry, I'm going to cancel out there. No way, that's not right. To the negative x well, in this case, again, try not to simplify until you're prepared to. Sometimes it can create some headaches, like getting rid of your integrand. So when you do take the derivative of this, this will be x e to the negative z from z to 0 u of z, which is essentially z e to the negative z minus z e to the negative 0. Sorry, the x 0 e to the negative z. So that's just nothing. And you're left with z e to the negative z u z. And for part B, we're given x minus y, and we'll make that equal to z. Similarly, we will find f of z through convolution of x z involved with fy of z. Now, because this is a minus y, it's not as pretty as this case. We'd want to get something that's equivalent to this. So another way to think of this would be is a negative y is equal to z minus x. Because of their independent random variable nature, we know that f of y is equal to f of y over g prime of y, value. So if you were to put a negative y in here, then the g prime of y would still be it'd be a negative 1, because y is the variable in this case. So if you were to sub in a negative for this, it would carry through and it would still be the same function. So we can use that to treat this as a negative z, still be the same, but it does cause us to have to kind of flip the signs in a way. So now we have a negative y coming in, and that changes the relationship of z minus x, because we would like to see that again here, z minus x. So now our x has to be a positive value here, plus the convolution. So once again with our integral, we set up e to the negative x, so negative x, u of negative x, e to the negative z minus x. So we do a little math substitution. And this is not going to work. This has to be changed as well. So that's an x. We can make u of negative x 1 minus u of x. So usually x is this way, so I'll change our where we care about to below x. So we'll distribute this, kind of have two functions now. So if you split that up, e to the x, e to the negative z minus x, multiplied by u of z minus x dx will be equal, well, no, sorry, not equal 1, we'll minus the integral 0, infinity to negative infinity, e to the x, e to the negative z minus x, u z minus x, u x dx. So again, we can start simplifying this with our various functions here. That's kind of like a 0. Tells us where that is. That line gets drawn. So from negative infinity to z, this is going to be a valid function of 2x, because x minus z plus x, so 2x e to the negative z dx minus from 0 to z, e to the 2x e to negative z dx u of z. So that was turn on after z, assuming z is at 1 in this case. So we kind of have two different before and after areas of 0. So we'll kind of pull out this, sorry, not that. We pull out the e to the negative z from both of these. And start doing our integration. So e to the 2x over 2, evaluated from z to negative infinity, minus e to the 2x over 2 from z to 0, u of z. Oh, I'm getting that it's not in view again, so we've just been kind of sussing out what we saw here earlier. Infinity, kind of take our we take our step functions and we use them to create our limits, and we can remove e to the negative z from both functions, and we're multiplying the entire function by that. So let's sub in now. E to the 2z over 2 minus e to the infinity, which is just negative infinity, which is 0. Let's see what it would go away. And then subtract e to the 2 z over 2 minus e to the 0, which is just 1. So 1/2. So e to the z of e to the 2z over 2 minus e to the 2z over 2 minus 1/2 uz. So if you think about evaluating this, when z is less than 0, when x, no, z's when z is less than 0, this isn't going to trigger, so we won't have any of that, so it's going to be e to the z multiplied by e to the 2z over 2, which is going to be equal to that's a negative z, so which makes that e to the z. One-half e to the z. And when z is greater than 0, that function will be triggered, and we'll have, you subtract this function from that, and these will cancel, and there'll be a positive negative 1/2. So, well, this will be, you know, this minus this plus 1/2. So it's going to be 1/2 e to the negative z when z is greater than 0. So fz of xy in this case is 1/2 e to the z, z less than 0, and it's 1/2 e to the negative z, z greater than 0. So it's a increasing and then decreasing function, which should have a area of 1 underneath its curves. So let's block that out, and then part C of this problem. Asks us, let's do z equals x times y, and we can leave f of z as an integral. So here we can, so we start by letting getting a dummy variable in here, x. And this leaves us with the equations z equals x, y, and w equals x, y equals w, and y equals z over w. So j x y is equal to y, x, 1, and 0, which is equal to negative x, which is equal to negative w. So for zw, it's going to be 1 over absolute value of that, f of xy, w and z over w. You can then use to get f of z, integral 1 over w, absolute value, fx, y, w, z over w, dw. And because we can leave it in integral form, that's as far as we can take that one. They call out to the lecture helpful in this case. And so for part D, we're given z is equal to x over y. And what we can glean from this is x is equal to zy. So then that means x and y are kind of linked, y equals x, in this fashion. So f of z is the probability x over y is less or equal to z. So f z is going to be equal to infinity, 0, yz, which is x, negative infinity of fxy, xy, x, dy. And this is also additionally y, so 0 to negative infinity yz, fx, y, xy, dx, dy. And one of these x's are easier to think of them as yz. So when one integrates yz from negative infinity to yz of this, you just get a negative y. You get a negative y in this case. You get a y in this case. Negative y, fxy, dx, or dd, that's just dy, dy. Sorry. When you integrate, you're taking out the y, you're integrating over y. Sure, integrating over x in this case. So dy. And that is just the absolute value of y multiplied by fxy of, yz and y dy. So substituting in here, substituting, we can kind of function this into one function and substitute in our functions. And we can use these to change our limits. So for example, this kind of makes it a 0 limit again for the lowest value. And we can just say, well, from infinity to 0, we have y e to the negative yz e to the negative y dy, trigger at z. So this gets us negative y, z plus 1, minus 1 over z plus 1 squared, multiplied by e to the y negative z minus 1, evaluated from infinity to 0. When you do that, you get negative infinity over z plus 1 minus 1 over z plus 1 squared, e to the negative 0 minus negative 0 over z plus 1 minus 1 over z plus 1 squared times e to the 0, and that's 1 to the negative infinity, which is 0. So that leaves you with a positive negative 1 over z plus 1 squared that triggers at z. And that is the PDF. Z of z. And that's the end of problem number 2. Thanks for watching.